Hi everyone, my name is Melanie, Math Content Specialist here at Zinkers. Let's take a look at another digital SAT question and how we can use Desmos to help us solve it. This question says, in the xy plane, the parabola has vertex 9, -14, and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constants, which of the following could be the value of a plus b plus c? My strategy for this question is going to be use Desmos to help us find some information out about A, B, and C, and then use some logical reasoning to choose the right answer from there. So the first thing I'm noticing is that we are given the vertex of our parabola, which is 9, -14. And I can use this vertex to write an equation of this parabola in vertex form. If you remember, vertex form is equal to this right here. Ax minus h squared plus k, where x and h are the coordinates of our vertex. Just note that the sign is switched for the one in the middle. And then a is telling us whether our parabola opens up or opens down, depending on the sign here. So I'm going to come over here in Desmos and type this in. X minus 9. Again, just be careful with that sign. And this should also be negative because my 14 is negative. I am going to add a slider in for A, and all this slider is letting me do is just play around with values of A, since I don't actually know it. And again, my strategy is, because my question is asking for the value of A plus B plus C, I'd like to find out some information about all three of those numbers. I might not be able to find them exactly, but I should be able to find out some information that's going to help me pick the right answer. So here I am going to just kind of see what happens when I play around with that value of A. If you remember just rules of quadratics, A is telling us if our parabola opens up or opens down. And if you notice, again, going back to the question, we want our parabola to intersect the x-axis at 2 points. The only way it's going to do that is if A is positive, A is greater than 0. And I'll prove that to you here with Desmos. If I just kind of play around with A, if I slide this slider up and down, when A is, here's A at 0, right? We just have a flat line. When A is negative, we can see our parabola open down, and it's not intersecting the x-axis at all. So we don't want that. If I slide my parabola back up to a positive value here at point 0.3, keep sliding all the way up. I could slide it up to whatever number I want. I can see that it is opening up and intersecting the x-axis at 2 points. So I know my A value should be greater than 0, should be positive. So in order to find some information out about B and C, I'm going to rely on the information I know about parabolas in general. And then I'm also going to manipulate this equation here that we came up with to, again, get some information out about B and C. So I'll start by just rewriting this equation we came up with. Again, this is vertex form. I'm going to rewrite it into standard form here, again, just so I can read B and C a little bit easier. And I'll do that just by distributing out this squared term. Just making sure I'm being careful with all of my signs and my multiplication. And I will end up with this. So first, let's just go back and check our work, make sure that everything makes sense so far. So here is my A term, right? A didn't go anywhere. There's my A. And then my B term is this right here, right? Negative 18A, that's my B. And then 81A minus 14, that's my C term. So if I just check out my B term really quick, negative 18 times A. So A is a positive number, right? And negative 18 is negative. If those multiply together, those should give me a B value that is negative. Let's double check that with Desmos and see if it makes sense. If you remember what we know about parabolas and quadratic equations, B is the value that tells us how shifted from the y-axis our parabola is. Because our parabola is shifted to the right of this y-axis, I know that my B value should be negative. And it turns out that the math backs that up. We do have a B value that is negative. Okay, what do we know about C? Again, reviewing rules of parabolas, we know that our C value gives us the y-intercept. And if I, again, just kind of mess around with my A value, that's going to change C. So look what happens when I do that. If I, again, keeping my A value positive, I can see that the only value here, really the only value that I'm seeing that's going to give me a negative C value is A being equal to 0.1. All these other values that I can mess around with do give me a positive C value, right? That parabola is intersecting the y-axis at a positive value. So I know for the most part, again, there seems to be maybe a couple of exceptions. For the most part, C is going to be positive. And I'll write a little note here, mostly, right? Not 100%, but for the most part, C is positive. So then if I think about A plus B plus C, if I'm looking for a positive value plus a negative value, again, plus another positive value, that is going to be mostly positive, right? I want to pick the value given to me that is the most positive option. Obviously, here we are given all negative numbers, but the greatest, most positive negative number I can choose from here is D, right? It is a possible value of A plus B plus C. It's the most positive I can get, and it lines up with everything that I found out from Desmos. So again, just with a little bit of logical reasoning, I can get to the correct answer of D. Is there another question that you want to see? Make sure to leave a comment down below, and don't forget to like and follow our channel for more digital SAT content.